3, nature of solids. So allotropes is when we have two or more different molecular forms of the same element in a physical state. And carbon, we've seen diamond, we've seen graphite, which is in a pencil, nanotubes are these, okay, and buckyballs. See, this is Buckminster fullerene, buckyballs, C60. We have these sort of spherical shapes, which are really cool. And these are all carbon. It's just that the atoms within the carbon align in a different way. Sulfur also can form sort of rings of 6, 8, or 12, which again just give it sort of a different structure, which is pretty cool. And important in terms of what properties it has. Obviously, you can think really easily about that with carbon, graphite being one and diamond being the other, because everybody sort of can visualize that or think about that. Okay. So phase diagrams show how state of matter changes as a function of temperature and pressure. So let's look a little bit at that. And we can see here that this obviously is under greater pressure, so everything's sort of compacted more at greater temperature and pressure than the diagram below. Okay, so this is a phase diagram for CO2, and what we have here is we have our solids are over here, our liquids are over here, and vapor is over here. And carbon dioxide can exist in solid, liquid, and vapor state. Okay, depending on the pressure and the temperature. And what we have here is this triple point right here in the middle, which is where all three conditions, all three phases will exist if we are at negative 56.6 degrees C and 5.11 ATMs or 518 kPa, all three conditions. So we will have carbon dioxide at solid, liquid, and vapor state. But anywhere else we go, we can see if we have a higher pressure, for example, and our temperature is still at that, around negative 56, we see that we have solid to liquid, which is our, melting or freezing. Okay, and here we have liquid to vapor, which if we go this one, we have condensing. But if we go to vapor, we are evaporating. And we have vapor to solid to vapor. So if we go this way, we have what's called deposition. And this way, it's sublimation. So if you go from a solid to a gas, we have what's called sublimation. Okay. Here's another phase diagram for you. This is carbon and sulfur, two of the ones that we just talked about. And these both have two triple points. So we have a triple point here for carbon where there's diamond, graphite, and liquid. And obviously diamond and graphite are both solids. Okay, but with higher temperature and higher pressure, we get diamond. And with graphite, it's just a lower pressure and lower temperature, but there's also liquid and vapor forms of carbon, and we have a triple point down here. So under different, you can see too that the temperature doesn't matter too much. It looks like it's very close to 4,000 K, but the pressure is really what determines the graphite versus diamond. And over here for sulfur, we have rhombic, which rhombus kind of looks like a diamond, like a rhombus. And monoclinic is kind of like needle-shaped. Okay, and then we have liquid and vapor, but you can see here too, just the temperature, how different the temperature is. And I don't know, that's 119 C. This is 96 C. All linear scales on the X and x-axis. Looks like it's different on the y. This is a phase diagram for water, and water also has a triple point. And for water, right here, okay, what we get is at about 0.61 kPa, and I can't write, I think it's about 0.016 degrees C, okay? So at that triple point, we'll have, this is vapor, this is liquid, and this is solid. We'll have water in all three phases, okay? The critical point up here is where both the liquid and the gas have the same density, and they're basically indistinguishable from one another. Okay. So phase changes that require energy. Version of water's phase diagram that you can see that we have temperature of about 0 degrees, which is where solid goes to liquid water, and pressure is about 1 atm at sea level, and then you have where we go from gas to steam is right at 100, and you can see your triple point here where all three exist at the same